All right. My favorite sixth graders in the world. Here we go. Today we're talking about how to find the volume of a pyramid. Now, we've talked about pyramids before. Pyramids have a base of some sort, whether it's a rectangle, whether it's a triangle, whether it's a square. And then from each side of the base, a triangle comes up and meets at a pinnacle at the top. So this is kind of a rough drawing of a pyramid here, but it's about as good as what Mr. Swack is going to do. Now, I've got two different formulas written here, and I want to point out that these two formulas are the exact same thing. I want to make sure we understand. If you actually were to research or look in your book, how to find the volume of a pyramid, most likely this first one is the one that you're going to see. Volume equals 1/3 capital B times height. Now this capital B, and I pointed out over here too, and I draw these arrows because I want to make sure you understand that. That capital B means the area of the base. It's not just saying base times height. The capital B means it's the area of the base. So for example, in this rectangle, which we're going to work to find the volume of it here momentarily, okay, I would find the area of the base by doing 5 times 3, because I can see that it's a rectangle based on the dimensions. I have a 5 here, a 5 here, a 3 here, and a 3 here. That shows me that that is a rectangle. All right, so I want to think about that. All right, and so that is just something to think about, that I'm finding the area of the base. Now, so I find that area, I multiply it by the height, which would be this dimension right here. Then once I get that answer, I can either multiply it by 1/3, or I can look at this formula over here, area of the base times the height, and dividing it by 1/3. Because we know from our rules of multiplying and dividing fractions, if I multiply something by 1/3, okay, when I do the flipping, it's the same as dividing it by 3/1. Or if I think of it vice versa, if I'm dividing something by 3/1, when I flip it to a multiplication sign, it's the same as multiplying it by its reciprocal, 1/3. So I want to just do that little demonstration at the beginning to make sure that you understand that these two formulas, even though they look different, are the exact same thing. If you do it right, you're going to get the same answer. I personally like to use this one better. It just depends on the numbers that you get, but sometimes dividing things by 3 is a little more straightforward than multiplying by 1/3. But really, in the end, it all depends on what numbers are there. Okay? So let's look at this triangle to start, because what you're going to be doing today is finding the volume of different, I said triangle, it's not a triangle, of different pyramids. Now, this is a rectangular pyramid because I see that it has a rectangular base. So when I'm going to apply the formula of area of the base times the height, the base is a rectangle. So I have to find the area of the rectangle. Well, it assumes, this assignment assumes that you know that to find the area of a rectangle, it's length times width, which is 5 times 3. Well, 5 times 3 is 15. So let's just make a note of 15 so we don't forget about that. But then the formula tells me I have to multiply that by the height. Okay, well, so I come back over here to my pyramid and I see that from the bottom of the pyramid to the top of a pyramid is a height of 8 inches. Okay, so I'm going to take that 15 and I'm going to multiply it by 8, which isn't hard to do. 8 times 5 is 40. Put the 0 down. Carry the 4. 8 times 1 is 8. Plus 4 is 12. I get 120. Then the formula tells me to divide by 3. Okay, that's what the formula tells me to do. So I'm going to take 120 and I'm going to divide it by 3. Now for 6th graders, really, I'm going to be honest with you, you should be able to use your zeros trick and do this mental math, because you should be able to think 12 divided by 3. That's a basic fact. 12 divided by 3 is 4. When I divide, I cancel zeros out until there's some left with one number, some left with another. There's no zeros over here. So this extra 0 here, I just have to put into my answer. The volume of this rectangular pyramid is 40 cubic inches. Remember, volume is done in cubic. If you had a Rubik's Cube, 1 inch long, 1 inch wide, 1 inch high, I could fit 40 Rubik's Cubes that size inside this rectangular pyramid. Now, let's look at something else, okay? There's a variety of things I want to point out to you. I'm just going to clear ourselves our space. This particular rectangular pyramid, I did such a good job drawing that I don't want to have to do it again, because I don't think I'm going to be able to do this well ever again. All right, so let's say, okay, I don't know. Let's say that I have, it's 11 feet tall, and it is 7 feet long, and it is 7 feet wide. Now here I should be able to reason that this is a square pyramid now, because this length is 7 and that length is 7. So if this is 7, this is 7. If this is 7, that is 7. So all 4 sides are the same, meaning that it's a square pyramid. So to find the area of a square, remember, I just take the length of one of the sides and square it. It's essentially the same as a rectangle in that length times width would be 7 times 7, or in a square, I take the length of one of the sides, which is 7, and square it, which is 7 times 7. Well, 7 times 7 is 49, okay? And then I have to take that, the area of the base, which was 7 times 7, which is 49, times the height, which is 11. So I'm going to come over here, and I'm going to do 49 times 11, which is a 6th grader. That's not too difficult of a multiplication problem to do. 1 times 9 is 9. 1 times 4 is 4. Put the 0 down so it all lines up with my 1. 1 times 9 is 9. 1 times 4 is 4. All right, then I'm adding these together. 9 plus 0 is 9. 4 plus 9 is 13. Put the 3 down, carry the 1. 1 plus 4 is 5. I get 539. Okay? But now I have to divide that by 3. Okay? So I've got to take 539 and divide it by 3. So I'm going to come over here and do that. 539. And divide that by 3. 3 can go into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. Bring the 3 down. 3 can go into 23 7 times. 7 times 3 is 21. 23 minus 21 is 2. I'm going to bring the 9 down. 3 can go into 29 9 times. 9 times 3 is 27. And 29 minus 27, I'm going to say that equals 2. So I get a remainder of 2. Now, if I wanted to, I could add decimal 0, but I'm not going to do that. I don't want you doing that, 6th grade. I don't want you adding decimals and zeros when you do division and you end up with remainders. This is where you almost use a combination of both formulas. And now I'm going to take this remainder of 2 and use a fraction mixed number sort of system. So if I wanted to rethink of this division problem, 539 divided by 3, as a fraction, we know that this is essentially what I'm doing. Okay, 539 divided by 3. Well, we've already established that 3 can go into 539 179 times. We've already established that 2 are left over. So that's going to be my numerator. My denominator here is 3. So my denominator here is 3. I get 179 2/3 cubic feet. You can kind of see my 3 there if I zoom in. All right, 179 2/3 cubic feet. So you're going to have to do that. You're going to have to keep yourself organized, 6th grade. It's not difficult, but you're going to have to keep yourself organized. Now, I want to point out a couple other things, okay? We're going to look at 2 more, but they're not always going to give you a picture of an actual pyramid. Sometimes they're going to say, okay, you have a square pyramid, and they just tell you it's a square pyramid. So you have to envision it in your head, okay? A base of a square, all 4 sides the same. From each base, a triangle going up to a point at the top. It tells you in this square pyramid, okay, that the length is 11 centimeters. It tells you that the width is 11 centimeters. And that would be common sense, because if it's a square, if one of them is 11, then the width also has to be 11. So that's really more information than they have to give you. You can kind of come to that conclusion, but they give it to you anyway. And then they tell you that the height is equal to 24 centimeters. Now, I remember my formula: area of the base times the height divided by 3. Sometimes you can use a little shortcut. And the reason I'm showing you this example is so you can kind of use the shortcut a little bit for those of you that, kind of get this pretty good and you want to kind of use some mental math shortcuts if you haven't already figured it out. Eventually I'm dividing by 3. Okay? So there's no reason why you can't divide by 3 at the beginning. If you see that one of the numbers is divisible by 3, you can actually just do that first. And I can see, well, 11 is not divisible by 3, but 24 is. I can do 24 divided by 3 and get 8. Okay? So now at the end, I don't have to go back and divide. So now if I find the area of the base, which is going to be 11 times 11, I know that 11 times 11 is 121. And then if I multiply that by the height, that would be 24. But I'm not going to use 24. I'm going to use 8. Because I did 24 divided by 3. I did my division by 3 early. So I'm just going to do 121 times 8. And 8 times 1 is 8. And 8 times 2 is 16. Put the 6 down, carry the 1. 8 times 1 is 8 plus 1 is 9. I get 968 cubic centimeters. And I can assure you that 121 times 8 equaling 968 is the same thing you would have gotten if you would have done 121 times 24. And then whatever that answer was, divided it by 3, you would have gotten 968. So you would have had a lot bigger numbers to work with. And the bigger numbers you work with, as I've said before, and the more problems you do, the more likely it is that somewhere you're going to make a mistake. We made it much simpler by just doing 11 times 11, which if we know our 11 times tables, we know that 11 times 11 is 121. And then I did my dividing of 24 by 3, which is 8. And then I just did 121 times 8, which is 968. Now, I want to look at one more thing so there's no confusion. All right? This time, it's a rectangular pyramid. So it's not a square. The length and the width are going to be different. All right? They're going to be different. So I'm looking at these here and I'm saying, well, okay. All right, let's say I have a length of 9 feet and I've got a width of 5 yards. All right, and I've got a height of 4 4/5 yards. All right, well, if we were really in a rush and not really thinking about what we were doing and reading what was happening, we might just go and do 9 times 5 and say, well, the area of the rectangle is 45. There's a problem with that, though, 6th grade. It's because Here they give you feet as a unit, and here they give you yards. They're different dimensions. They're different units. So if we're going to have different units, we have to make them all the same. The numbers won't work. We can't just carry out the formula of area of the base times the height divided by 3 and make that work. It's not going to happen because we have to have all the units the same. So I've got to remember back in the day of maybe even 5th grade of what the connection is between yards and feet. And I should remember that it's 3 feet that equals 1 yard. I should remember that conversion of 3 feet equaling 1 yard. But I have 9 feet, okay? So I need to figure out how many yards are in 9 feet. Well, going from feet to yards, since I know that 3 feet is 1 yard, 1 foot is smaller than 1 yard. So my measurement is getting bigger, which means my number is getting smaller. To figure out how many yards are in 9 feet, I've got to do 9 divided by 3 because there's 3 feet in a yard. Well, 9 divided by 3 is 3. So 9 feet equals 3 yards. So the first thing I want to do is get rid of this 9 feet and make it 3 yards. All right? Now I can figure out the area of the rectangle, because the area of the rectangle is length times width. So that's going to be 3 yards times 5 yards. Well, the area then is going to be 15, because 3 times 5 is 15. And then I'm going to have to take 15 and multiply that by the height, which is 4 4/5. But I'm noticing that 15 is divisible by 3, because remember what the formula is area of the base times the height divided by 3. Well, just like I did in the previous example, I'm going to make a little shortcut, and I'm just going to divide now. I'm going to try to use a smaller number in my multiplication and then not have to go back and do a confusing division problem. So I'm just going to divide this number by 3. And 15 divided by 3 equals 5. Okay? So what I'm left with now is my 5 yards being multiplied by the height, which is 4 4/5. So now I have to remember about my rules of multiplying things with fractions. So let's clear a little space. 5 4/5. If I want to turn 5 into a fraction, it becomes 5 over 1. 4 4/5, to turn a mixed number into a fraction, 5 times 4 is 20, plus 4 is 24. So it's going to become times 24 over 5. Well, I can't cross-check a 1 and a 24. Nothing can go into either one except 1. Nothing can go into both of them except 1. Well, my 5s can both be divided by 5, so those are both going to become 1. Okay? Well, 1 times 24 is 24. 1 times 1 is 1. And 24 divided by 1 equals 24, which means that the volume of this rectangular prism is 24 cubic yards. I'll be available to help during the Zoom time on Wednesday, April the 22nd. All right, have a good day, 6th grade. We'll talk to you later.